Hello everyone, let's learn about binary number system today. Binary number system is really fascinating, very interesting, and it's very easy, even though it sounds kind of fancy, but it's not. It's just same as our decimal. Mostly we use decimal numbers. So what is number system? Number system is a system in mathematics that's used to express numbers in various form. It's also called system of numerations. So there are maybe many number system, but basically we use binary, octal, decimal, and hexadecimals. And everyday use we use the decimal one, the number 3, and then all the others, binary, octal, hexadecimals, related to computer programming. So binary means it's actually two numbers which are basically only 0 and 1. So so binary is only 0 and 1. Octal is start from 0 to 7, so 2, 3, 4, 5, 6, 7. This is called octal because it has only 8 digits, is from 0 to 7, and binary is 2 digit. And then we have decimal, which is basically the everyday use we use every day. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This is decimal number system. And there is another number system mostly used in computer programming, and even if you draw or do something, you might see every paint color, every different color, it has a different number system. They use hexadecimal. So what is hexadecimal? Hexadecimal, it has 16 digits. It starts from 0, 2, 3, 4, 5, 6, 7, 8, 9. So instead of 10, they write A. And instead of 11, they write B. Instead of 12, they write C. Instead of 13, they have D. Instead of 14, my bad, my handwriting is really bad. So D, A, B, C, D, E, F. So these are this is the hexadecimal because it has 16 digits to in its counting in its counting system. Now let's talk about the binary, how we increase the numbers. So we are familiar with the decimals. We know how to count from 1 to 100, or from 0 to 100, or maybe more. So we know how to write decimal numbers, 4, 5, 6, 7, 8, 9. So how do you write the 10? So you can see from 0 to 9, these numbers has different shape, right? So from 0 to 9, every digit has its own shape. But if you want to write 10, you don't have a different digit. So what do? You write 0 and then bring the first number here, and you increase like 11, 12, 13, go on and on. And imagine if you ended up at 99, you don't have a different number for number 100, right? So what do? You put a 0 and 0 and bring the first number here, the number 1 here, the digit, and then you start to count again. 101, 102, just like that. This is the pattern to increase the number. This is the decimal. But now, how do we write binary? Binary has only 2 numbers, right? So how do we increase the binary? Well, we have just same way, just same pattern, just like this one. same pattern just like this one, right? So you don't have a different number, the third number with a different shape, right? So you put it 0 and then you put it 1 and you increase. So you can increase the number. Instead of 0, you can increase to 1, and now you run out of digit, right? You run out of new digit. What you do, you put a 0 and 0 and bring the number 1 here. So that's how you count. You go on and then 1 0 and then to 1 1 and then here. So when you run out of numbers, new number, what you do, you put 0 and 0 and increase the number. This is how the in the increment of the number works. So, and also we should remember that on the left side of the number you can put zeros as many as you want. You can put billions of millions of zeros. It doesn't matter, the value remains same, the value stay the same. So these binary numbers, so who use binary numbers? Of course, these binary numbering system used in computer programming. But it's good to know, it's good to learn how to write the binary numbers. Now let's learn how to convert the binary numbers to decimal numbers, or decimal numbers to binary numbers. So in binary numbers we have a patterns, or we call it place value. So imagine sometimes you might have a binary numbers, just like, you know, if you heard about the Unicode or some other you know, numbering system in the computer, everything is related to this, you know, binary code. So imagine I write a number like let's see, 1 1 1 0 1 1 0. So how many now? 8 1. So let's make this more clear. So, and again in binary they use 8 digit. Mostly you can binary system, we have 8 digit, or we can it 1 byte. So if you're, I know you are familiar with the byte, you know, one if you use phone, if you use computer, you heard about GB and MB, just like that. So in binary systems, 8 bits is equal to 1 byte. Sorry, is equal to 1 byte. So, and bit means digit, so 8 digit is equal to 1 byte. So 1000 byte equal to 1 KB, and 1000 KB is equal to 1 MB, and 1000 MB is equal to 1 GB. Just like this, just like that happened. Is not actually 1000, it's actually more than 1000. The real figure is 1024. But anyway, so now if you have there is a pattern to convert any binary numbers to a decimal number. So this is the pattern. So what happened here, we use a place value of the binary. So the first place value, this is second place value 2, and the third place value is 4. What happens is actually you multiply every number with the 2. So 2 times 4 is 8, 8 times 2 is 16, 2, and then 16 times 2 is 32, and 32 times 2 is 64, and 64 times 2 is 128. So so what happened here, so imagine this is the binary number you have, and you have to convert it to the to the decimal number. So what happened, you can see every you just have to pick up the wherever the one number, wherever is 1, you just mark that number. Wherever 1, you just mark that number. Mark this number. Sorry, let me use a different color. Okay, so mark this number. Wherever 1 is, mark this number. Wherever 0 is, ignore it. Whatever 1, so 0 0, and add up all the numbers. So like 180, 64, 32, 8, 4, 1. So when you add up all this number, right, so 128 times 64 is 192, add 32, add 8, add 4, add 1. So the number is, in the decimal, is 237. So this is how you find out, you convert a binary number to a decimal number. And also same way you can find out the decimal number, a decimal number to a binary number. So imagine you have a number, you have just a number like, okay, you have a number of you use the same pattern with this one. So imagine you have a number of let's say 100. So what is the binary number of 100? This is a decimal, and what is the binary number of 100? So the easiest way, what you can do is actually you subtract, write down the number 1, this number. So you subtract 100, you subtract 128 from 100. Can you subtract from 100 to 28? If you know, write it 0. And then can you subtract 64 from 100? Yes. So subtract 100 from 64. 10, 6, you have here 9, 36. So, and again, go to the next number. Can you subtract 32 from 36? Yes. So if it is yes, put it 1. And 32 then 6 is a 4. And again, come here, so oops, come on. Now go back to the remaining number. Now you have the number 4. Can you subtract 16 from 4? No. Can you subtract from 8 from 4? No. Can you subtract 4 from 4? Yes. Yes means 1. So when you subtract 4 from 4 is actually 0. So all the numbers are 0 0. So this is the binary numbers. Binary numbers of 100. See, this is very easiest way to convert decimal number from decimal to binary, or from binary to decimals. So this is very easy. So why the binary number is important? Because in computer programming, every let me show you something else. In computer programming, every letter, every symbol, whatever they have, every number has a binary, binary code. Now imagine, you know, when we say hello in English, when we say hello, we understand. When you look at it, when you hear, we understand hello means hello. But computer doesn't understand this letter. Computer only understand with binary numbers, or with, you know, the numbers. So how computer see hello? Let me show you. So computer see hello just like this. Okay, I have to go to the okay, see. So when you write hello in text, but this is the binary. So in the binary, what happened here, let me copy that, go back to the whiteboard. So this is the binary system. Okay, this is the binary numbers of the hello, and when you type this is how you communicate with the computer. And every binary code is actually had 8 digits, or 1 byte, as I said before, 8 digit to equal to 1 byte. So 8 digit numbers. So every 8 digit number has a corresponding decimal number, and it has, so when we talk about the H, when we talk about the H, let me find out the Ascii table chart to make it more clear about the binary code and then Unicode system. It's slow today. Come on. Okay, Ascii, I think I have it here. Okay, here it is. So here, now look at this Ascii code. You see here. Now look at here. This is the number different. You know, every decimal numbers has a corresponding octal, hexadecimal, and binary code. So this is how computer understand the letters or the symbol. And imagine if you want to tell the computer number 1, you have to put this binary code, this one. This is how the understand the computer understand you the programming instruction. So this is the 49 is the decimal numbers for the corresponding to the binary numbers. And imagine, so now let's copy that number and let's see how we find the decimal number of this binary code. So as I said before, you have to follow the pattern. Let me remove this everything. Let me just copy that binary code and follow the one we used before, right? So the pattern is the place value of the 8 binary digit is 1 2 4 8 8 6 16 32 64 and then 128, and then 16. Let me just, okay, now let's write the binary code here. So what is the binary code here? 1, let me use a different color. Okay, so it's 1 0 0 0 1 1 0 0, right? So as I said before, wherever there is 1, just circle that number. Wherever is 1, the circle that number. Wherever is 1, then circle that number. So, and after that, you know, add up all the number together and you will find the decimal number corresponding to the binary number. So what is now? 32 plus 16 is actually 48, and 48 plus 1 is actually 49. So this is the corresponding code of decimal number 49 in binary. And then when you go back to the ASCII table chart, then you will find out, so 49 in decimal, and then 00110001 in binary number means actually number 1. And that's how computer understand our communication. So I believe you have understand the binary code, how to write, how to increase, how to convert from binary to decimal, from decimal to binary. And if you follow this place value pattern systems of the binary, you can easily convert binary numbers to decimal or decimal numbers to binary. And this is the easiest pattern. Just remember the place value of the binary in the 8 digit. We go from right to left. So 1, 2 times 4. So 2, 4, 8, 16, 32, 64, 128. That's how we find any binary numbers and decimal numbers using these patterns. Thank you so much. If you have any questions, or if you have if you understood the binary number systems, just thanks me.